Okay, so get this. Today's deep dive is going to be about a hidden danger. Flammable metals. Yeah, you heard that right. You probably think of like wood or paper when you think of something catching fire, right?
Right.
Not a big chunk of metal. But get ready for a surprise. Because under the right, or should I say wrong conditions, metals can be a serious fire hazard.
Yeah.
I've got this article here called Is Metal Flammable? Understanding the Risks and Hazards in Industrial Settings. And let me tell you, it's got some seriously eye-opening stuff. So our mission today is to uncover what makes metals flammable, which ones pose the biggest risks, and what safety measures are crucial, particularly in industrial settings where these metals are often used.
Yeah, so good.
So expert speaker, the article dives right into this idea that not all metals are flammable in the same way. Can you break down why a solid block of steel might be safe, but metal dust is a different story?
Yeah, sure. So it all comes down to surface area. If you imagine you have a solid block of metal, the oxygen in the air can only react with the surface of that metal. But if you were to grind that block into a fine powder, suddenly you have millions of tiny particles, each with its own surface exposed to oxygen.
Right.
And that drastically increases the rate of reaction, making it way more likely to ignite.
So it's not just about what the metal is, it's also about the form it's in.
Exactly.
Okay, that's kind of mind-blowing. The article also talks about something called chemical reactivity. What's that got to do with metal fires?
So some metals are just naturally more reactive with oxygen than others. They're practically itching to combine. Think of magnesium. You know how it burns with that super bright white light in fireworks?
Yeah.
That's because it's highly reactive with oxygen. Aluminum, titanium, and zirconium are also pretty high up there on the reactivity scale.
Speaking of zirconium, that sounds like something straight out of like a sci-fi movie.
Right.
Where do we even encounter zirconium?
Well, you might be surprised to learn that zirconium is actually used in nuclear reactors. Yeah, it's got this unique ability to resist corrosion and withstand high temperatures, making it perfect for that kind of environment. But there's a catch. It reacts violently with water.
Oh, no.
So you definitely don't want to be around if there's a zirconium fire and someone tries to put it out with water.
That's a story waiting to happen. We're maybe not considering the whole nuclear reactor thing.
Yeah.
Okay, so we've got surface area and reactivity.
Yeah.
But the article also mentions ignition temperature. Is that like how hot something needs to be to actually catch fire?
Yeah, exactly. The ignition temperature is the minimum temperature a material needs to reach before it will burst into flames.
Okay.
So it's like a threshold. Once you cross it, things get fiery.
So it's not just about having, those other conditions in place. You need enough heat to actually get things going.
Right.
Makes sense. Now, for a little pop quiz, you mentioned a bunch of flammable metals. Which one besides zirconium is known for burning with a super bright light that can seriously damage your eyes?
You're talking about magnesium again? It's not just in fireworks, though. They use it in things like flares because of that incredibly bright light it gives off.
So that's why they tell you not to stare at flares. It all makes sense now. The article also mentions that magnesium fires are classified as Class D fires. Why are they treated differently?
Well, metal fires burn way hotter than your average wood or paper fire. We're talking thousands of degrees.
Really?
Yeah, and because they burn so hot, you can't just put them out with water. In fact, adding water to some metal fires can actually make them worse, even causing explosions.
Wow, that's wild. So what do you use to put out a metal fire?
You need a special type of fire extinguisher, a Class D extinguisher. These are usually filled with a dry powder that smothers the fire and cuts off its oxygen supply.
Okay, so we've covered why metals can be flammable and what makes them catch fire. But what about preventing these fires in the first place? The article mentions OSHA and NFPA guidelines. Are those like the safety Bibles for dealing with flammable metals?
Yeah, they're pretty much the gold standard for workplace safety when it comes to these materials. Think of it like this. OSHA and NFPA lay out a roadmap for identifying the risks, controlling the hazards, and training everyone on how to handle these metals safely.
So it's not just about reacting to a fire, it's about creating a culture of safety where fires are less likely to occur in the first place.
Yeah, exactly.
That makes a lot of sense, but I'm curious.
Yeah. About shifting from a reactive approach to a proactive one. And one of the key elements of that is understanding the specific properties and applications of different flammable metals.
Okay, so let's get specific. We've talked about magnesium, aluminum, titanium, and zirconium. They all sound pretty exotic. Are they just used in, like, niche industries?
Not at all. These metals are surprisingly common. Take magnesium, for example. It's incredibly lightweight and strong, which makes it ideal for use in things like car parts and aerospace components.
Right.
But that same lightness also makes it useful in things like biodegradable implants.
Well, biodegradable implants.
Yeah.
As in they dissolve inside the body. That's amazing. But also kind of freaky considering we're talking about flammable metals. How does that even work?
It's all about controlling the rate of oxidation. Researchers have figured out how to create magnesium alloys that degrade slowly and safely within the body, providing temporary support while the body heals.
Wow.
It's a fascinating example of how we can harness a metal's reactivity for good.
Yeah, it's incredible. It's amazing how something that can burn so fiercely can also be used in such a delicate and precise way. Okay, what about aluminum? I mean, it's everywhere. Soda cans, foil, airplanes. Surely it can't be that flammable in those forms, right?
You're right. A solid chunk of aluminum isn't going to spontaneously combust.
Yeah.
But when it's finely powdered, like in dust form, that's when things get tricky. Remember how we talked about surface area?
Yeah.
The same principle applies here. Aluminum dust is highly flammable and can even create those explosive dust clouds we talked about earlier.
All right. So keep your aluminum foil away from open flames, folks. But seriously, where would these dust clouds even be a problem?
Think industrial settings where aluminum is processed. Places like factories and mills. If dust isn't properly managed, it can accumulate in the air, creating a serious fire hazard.
So it's not just about the metal itself. It's about how it's handled and processed.
Right.
That makes sense. What about titanium? The article mentioned it's used in things like aerospace and even medical implants. Sounds pretty high-tech.
Yeah, titanium is an incredible metal. It's strong, lightweight, and incredibly resistant to corrosion. But here's where things get really interesting. 3D printing.
Okay, 3D printing. Everyone's talking about that these days. What's the connection to flammable metals?
Well, 3D printing often involves using metal powders, including titanium. And remember, those fine metal particles are highly flammable.
Right.
So managing that flammability risk is a big challenge for the 3D printing industry. They have to develop specialized safety protocols and equipment to prevent fires and explosions.
So even cutting-edge technologies have to grapple with these age-old fire hazards. Huh. It puts things into perspective. Now we've got one last metal on our list, zirconium. You already told us about its role in nuclear reactors and its explosive relationship with water. Anything else we should know about its flammability?
Well, what makes zirconium particularly interesting and dangerous is its pyrophoric nature.
Pyro what now? That sounds like a superpower.
It basically means it can ignite spontaneously in air. No spark, no flame needed. Just exposure to oxygen is enough to set it off.
Whoa, that's seriously intense. So you're telling me that zirconium powder just bursts into flames on its own?
That's the gist of it, yeah. It's why handling zirconium requires extreme caution and specialized knowledge.
Okay, I'm officially adding zirconium to my list of things to handle with a 10-foot pole. So we've talked about magnesium, aluminum, titanium, and zirconium. All amazing metals with unique properties, and as we've learned, some pretty intense flammability issues. But let's shift gears for a moment. We've talked about why these metals are flammable and some of their interesting applications. But what about the practical side of things? How do we actually prevent and manage these fires in real-world settings, especially in industrial environments?
That's where those OSHA and NFPA guidelines we mentioned earlier really come into play.
Okay.
They provide a framework for creating a comprehensive fire safety program.
Okay, break down for us. What are the key components of a solid fire safety program?
First and foremost, you need a thorough hazard assessment. This involves identifying all potential fire hazards associated with flammable metals in your workplace. Things like storage locations, processing methods, potential ignition sources, and the types and quantities of metals being used.
This is like doing a deep dive into your own workplace to uncover any hidden fire risks.
Exactly. And once you know what you're dealing with, you can start implementing control measures. This might include things like designing and implementing proper storage procedures, investing in dust collection systems and ventilation to prevent those hazardous dust clouds, implementing strict controls on ignition sources like hot work permits and restrictions on open flames.
Sounds like there are a lot of moving parts.
There are, and it's not just about putting the physical measures in place, it's also about having a robust training program. Everyone who works with these materials needs to be aware of the hazards, understand safe handling procedures, and know what to do in case of an emergency.
Right. It's about building a culture of safety where everyone's on the same page. But let's say, despite all the precautions, a fire does break out. What then?
That's where a well-rehearsed emergency response plan comes in. Everyone needs to know exactly what to do, evacuation routes, assembly points, who to contact, and most importantly, how to use those Class D fire extinguishers we talked about.
So it's not just about preventing fires, it's about being prepared for the worst-case scenario. That's a lot to think about.
It is, but here's another layer to consider. The building itself.
Wait, you mean the actual structure of the building can play a role in fire safety?
Absolutely. The materials used in construction can make a huge difference in containing a fire and preventing it from spreading.
So what are we looking for in a fire-resistant building?
Think materials like concrete and masonry, which are naturally fire-resistant. They can withstand those high temperatures without adding fuel to the fire. And even when using steel, which is a common structural material, it can be coated with fire-resistant materials to protect it from the heat.
So it's like giving the building its own fireproof armor.
Exactly. And then you have things like fire-rated doors and windows, which act like barriers to compartmentalize a fire and slow its spread.
Wow, it's amazing how much detail goes into creating a truly safe environment. It's a whole system, not just a few isolated measures. But before we wrap up this part of our deep dive, is there anything else you want to emphasize about fire safety? Anything our listeners should really take to heart?
Fire safety is an ongoing process. It's not something you set and forget. It requires constant vigilance, regular training, and a commitment to continuous improvement.
Yeah, it's like a constant feedback loop. Assess, just repeat. Can't just check it off a list and call it a day. Speaking of ongoing processes, what about personal protective equipment, PPE? It seems like the kind of thing you'd need to pay close attention to when dealing with flammable metals.
Oh, absolutely. PPE is that last line of defense between a worker and a potential hazard. And when you're dealing with the kind of extreme heat and reactivity that flammable metals can produce, having the right gear can be the difference between, a minor incident and a serious injury.
Right. Okay, so let's talk specifics. What are the essential pieces of PPE for someone working with these metals?
Well, it really depends on the specific job and the types of hazards involved, but some of the common items include fire-resistant clothing, heat-resistant gloves, eye protection like goggles or face shields, steel-toed boots, and even respirators if there's a risk of inhaling metal dust or fumes.
That's quite a list. But having the gear is only half the battle, right? You need to know how to use it properly.
Exactly. A loose-fitting jacket or a scratched-up face shield isn't going to provide adequate protection. PPE needs to be properly fitted, worn consistently, and inspected regularly for any damage. And of course, everyone needs to be trained on how to use and maintain their gear.
It all circles back to that culture of safety we were talking about. Everyone needs to be informed and empowered to take responsibility for their own safety and the safety of those around them. Well, we've covered a lot of ground in this deep dive. From the seemingly harmless metal dust to the intricate world of fire safety regulations and the vital role of personal protective equipment. Is there anything else about flammable metals that you think our listeners should know?
It's easy to get caught up in the technical details, the different types of metals, the fire safety protocols, the PPE requirements. But what really fascinates me is how all of this ties back to a fundamental principle, the interconnectedness of things. We've seen how seemingly harmless materials can become dangerous under certain conditions. How even cutting-edge technologies like 3D printing have to grapple with age-old fire hazards, and how individual actions and choices can have ripple effects throughout an entire workplace.
Yeah, it's a reminder that we're all part of a larger system. And safety is something we create together through knowledge awareness and a shared commitment to protecting ourselves and each other.
Precisely. And I think that's a powerful takeaway for anyone, regardless of their profession or their level of knowledge about flammable metals.
Couldn't agree more. So to our amazing listener, we hope this deep dive has sparked your curiosity and given you a new appreciation for the hidden dangers and surprising applications of flammable metals. Remember, knowledge is power, and staying informed is the first step towards creating a safer world for ourselves and those around us. Until next time, stay curious.